I'm going to do a quick review on some of the problems, weight and balance calculations that are found on Prepware. So the first one that I have says, the datum is forward of the main gear center point 30.24 inches. The distance between the tail gear and main gear center points is 360.26 inches. The net weight at the right main gear is 9,980 pounds. The net weight at the left main gear is 9,770 pounds. The net weight at the tail wheel is 1970, so 1,970 pounds. So that's the aircraft pushed onto the scales, weighed. Now, next we have these items were in the aircraft when it was weighed. Lavatory water tank full, 34 pounds at an arm of plus 352 inches, so positive 352 inches. Hydraulic fluid, 22 pounds at negative 8 inches. Removable ballast, 146 pounds at 380 plus 380 inches. And it wants us to find the empty weight center of gravity. So for this problem, I've split it up into a chart. So what I got here is the right main gear was 9,980 pounds at an arm of plus 30.24. The left main gear, 9,770 pounds at plus 30.24. Now, the tail wheel did not give us a specific arm, but what it did tell us was that it was 360.26 inches away from the center point of the main gear. So if the main gear is 30.24 inches from the datum, we can add 30.24 inches plus the distance between these two to equal the tail wheel's distance from the datum. So we have 390.5 inches from the datum. And here's where, is this backwards? No. Here's where it starts to get a little bit confusing now. I've had issues with this problem in the past. I do understand it now as of today. We've got, if you remember, I said that there were 3 items included in the aircraft when it was weighed. So we had hydraulic fluid, water, and a temporary ballast. When we calculate this center of gravity, we're going to leave out the hydraulic fluid. The reason we're doing that is because hydraulic fluid is included in the empty weight. So we don't need to add it because these values already account for that 22 pounds. But what we do need to do is subtract the 34 pounds that was water, because water tanks are not included in the empty weight, and removable ballast, which was 146 pounds, which is also not included in the empty weight. So the way that we calculate center of gravity is the weight times the arm equals a value called the moment. So what I've done here is multiplied this weight by this arm to equal this moment. 9,980 times positive 30.24 to equal this moment. That times that to equal this. This times this to equal that one, and so forth. So once you've calculated all the moments, what you do is you add up all the values that we have for weight. If it's a negative, it's subtracted. The moments, add up all these values. If it's a negative, it's also subtracted. And then what we do is we take our total moment divided by our total weight, and that's going to equal the center of gravity. So our total weight looks like it's 21,540 pounds. Our total moment is 1,299,077 pounds. Or I guess maybe it's not pounds. Doesn't really matter. But anyways, this total moment is divided by this total weight, and the center of gravity that comes out, or not the, no, yeah, center of gravity comes out to be 60.31. I guess we can do this one. Well, that's not, yeah, it's fine. So this one says, an aircraft with an empty weight of 2,100 pounds and an empty weight CG of plus 32.5 was altered as follows. 2 seats, each weighing 18 pounds, were removed at an arm of positive 73. So 18 times 2 is 36 pounds. We removed it, so the weight's going to be negative, and the arm is positive 73. Structural modifications were made that added 17 pounds at an arm of positive 77. Then a seat and seat belt were added. They weighed 25 pounds, installed at positive 74.5 arm. And finally, a radio was installed, so that's plus 35 pounds at a arm of plus 95. So it's not very different from the last one. The only reason that this one's a little bit more difficult is you just have to make a slightly longer list and multiply the weights by the arms, get a list of moment values. And what you'll see here is we've only got the weight of the structural modifications. So 41 pounds total modifications were made to this aircraft, giving us a moment of this value. So we don't have an original moment value, but we need one to be able to calculate the CG. We do have an original empty weight, and if we know that this 41 pounds was added, we have a new weight of 2141, so 2,141 pounds is the new empty weight. For the new moment, we have this, and we need to find what the old moment value is so we can add them together. The way that you do that is if you look at this formula right here with the center of gravity is equal to total moment divided by total weight. If we multiply our total weight by our center of gravity, that will equal our total moments, which that ended up coming out to be 68,250 was the original moment of the aircraft. We add the new moment that we just calculated, 3,868.5, give us a total of 72,118.5 is the new total moment, divided by the new total weight is going to give us a new CG of 33.68. Remember, our old CG was 32.5, so it moved just a little bit. Okay, I'll go ahead and do this one now. This one's actually very simple. This one just says, an aircraft ass loaded weighs... Actually, I don't want to do that one. Sorry, people. Okay. When an empty aircraft is weighed, the combined net weight at the main gears is 3,540 pounds with an arm of 195.5. Now, notice that we were not given a positive or a negative value yet. At the nose gear, the net weight is 2,322 pounds with an arm of 83.5. Still no positive or negative value. The datum line is forward of the nose of the aircraft. What is the empty CG of the aircraft? So we know these weights, and we know the arms, but we don't know if they're positive or negative. What we do know, however, is that the datum line is forward of the aircraft. When the datum line is forward of the aircraft, all values of the arms are positive. The only situation in which an arm is negative is if, let's say that the datum is at the firewall. Everything that would be forward of that datum would have a negative arm. Everything that is aft of the datum has a positive arm. So since our datum is located at the nose of the airplane, all the values are going to be positive. So we have, for the main gear, our total weight was like 3540. And then the nose gear, 2322. The arms, plus 195.5 and plus 83.5. So all we do is multiply this weight by this arm to get a moment, multiply this weight by this arm to get a moment, add up the weights, add up the moments, and then divide total moment by total weight to get us a CG of 151.1. Pretty simple for that one. Now this is the only one that's kind of a curveball, but it's really simple because it comes with a formula. So the question says, an aircraft as loaded weighs 4,954 pounds at a CG of plus 30.5. The CG range is 32 plus 32 to plus 42.1. Find the minimum weight of the ballast necessary to bring the CG within the CG range. The ballast arm is plus 162. So from what we can see in this question, the center of gravity is at plus 30.5, which means that it is not within the range of 32 to 42.1. When that happens, what we can do is add a ballast at a location in the aircraft to bring the CG within range. In order to calculate the weight of the ballast that we need to bring the CG within range, we have a formula for ballast weight. So it says ballast weight is equal to the empty weight times the distance out of limits divided by the distance between the ballast and the desired CG. So it's a lot easier than you would think. The empty weight, what we know, is 49.54, or not 0.54, 49.54, so 4,954, sorry. And so then we need to multiply that by the distance that it's out of limits. So if our CG is at 30.5, and we know that the range is 32 to 42.1, we just need to bring it to the minimum, which is 32. So what we would do there is say 32 minus 30.5 to figure out how many inches is between them. So in that case, it's going to be 1.5 inches between 30.5 and 32. And then on the bottom, we have the distance between the ballast and the desired CG. So we were given in this question the ballast arm, which is going to be the location on the aircraft, at plus 162. So if our desired CG, like we just noted, is going to be the minimum of that range at 32, we need to find the distance between where the ballast is located at 162 and where the CG is going to be located at 32. So what we would do is take 162 minus 32, find that that's 130 inches in between, and then all you have to do is do this math, and the ballast comes out at needing to be a weight of 57.16 pounds. So it's really simple. Here's that formula again. I don't know if it's visible. Okay, yeah, it's visible. And that is all. That is all that I have.